So, what if I told you that the absolute hardest, most rigid part of your body is also one of the most alive and dynamic? Today, we are diving deep into the skeletal system, and I promise you by the time we're done here, you are never going to look at your own bones as just a simple, static scaffold ever again. You know, when we see an image just like this, our brain immediately jumps to something kind of rigid, unchanging, maybe even a little bit spooky, right? It's just the frame that holds us up, the passive architecture of our body. But honestly, that whole idea couldn't be further from the truth. And that's really the big question we're going to tackle today. Because the reality is, your skeletal system is a living, changing, and incredibly active part of you. It is constantly busy, breaking itself down and rebuilding itself based on how you live your life. And that process, as you're about to see, is pretty remarkable. Okay, so to really understand how something so strong can be so alive, we've got to zoom way, way in. We need to start at the molecular level and look at what bone is actually made of. Now, this definition right here, it just shatters that old myth. Forget thinking of it as inert rock. I want you to focus on these keywords: living, highly vascular, and regenerative. Highly vascular just means it's packed with blood vessels. This tells you that bone is a dynamic material, constantly being fed, constantly healing, and always adapting. So how does bone pull off this incredible trick of being both strong and alive? Well, it's basically engineered as this brilliant composite material. Think of it like reinforced concrete. About 2/3 of it are these inorganic calcium salts, that's the concrete part, giving it hardness to resist the crushing force of your body weight. But the other third, that's a web of organic collagen fibers. And that's like the steel rebar in the concrete, giving it toughness and flexibility so your bones can actually bend a tiny bit without snapping. And that combination is just astonishingly effective. I mean, get this. Gram for gram, the very material you're made of is engineered to be as strong as steel. That's just an incredible feat of natural design. Okay, so now that we get the material, let's zoom out a bit and look at the blueprint. How are all these incredibly strong bones arranged to build our entire skeletal system? The whole framework is really elegantly organized into two main parts. So over on the left, we've got the axial skeleton. That's your skull, your spine, your rib cage. Think of this as your body's central pillar, the core that protects all your most vital organs. And then, attached to that, you have the appendicular skeleton, your arms, legs, shoulders, hips, basically everything designed for movement and interacting with the world. And this system is the ultimate multitasker. Seriously. I mean, sure, it provides our shape, that's the obvious one, but it also acts as a system of levers for our muscles, protects our brain and heart like a suit of armor, and it's a critical mineral bank, storing almost all of our body's calcium. Oh, and plus, deep inside the bone marrow, it's a factory manufacturing millions of new blood cells every single second. It's wild. Of course, not all bones are created equal. Across this whole system, you see this incredible specialization. The specific shape of every single bone is perfectly adapted to what it does. So let's take a quick tour of how this plays out. First up, we've got the long bones, like the femur in your thigh. That long shaft, it acts as a perfect lever. So when your powerful thigh muscles pull on it, they generate those big, sweeping, forceful movements you need for walking, running, and jumping. Then you've got the short bones, like this little cluster of carpals right in your wrist. These small, cube-like bones are designed to just slide against each other. They give you a stable, strong base for the thousands of tiny, intricate movements your hand makes, from grabbing a cup of coffee to typing on your phone. Flat bones are basically the body's natural armor. Your ribs, your sternum, the plates of your skull, these are all broad, thin structures designed for one primary mission: protection. They form the rigid walls that shield all our most delicate organs. And finally, we have the wonderfully weird, irregular bones. I love these guys. These are bones like the vertebrae, and their complex, unique shapes just don't fit into any other category. And that's because they're custom built for highly specific jobs. In this case, protecting your spinal cord while also bearing weight and allowing for flexible movement. So we've seen all the different bone shapes across the body, but what's actually going on inside one of them? Let's zoom right in and check out the anatomy of a typical long bone. So you can see right here how those functions are built into the design. You have the long central shaft, the diaphysis, which gives you all that leverage we talked about. Inside that is the cavity that's home to our blood cell factory, the bone marrow. And then you have the expanded ends, the epiphyses, which are coated in super smooth cartilage to form our amazing, nearly frictionless joints. And this really just proves our main point. A bone is not dry. It is absolutely humming with life, fed by a complex and rich blood supply. You've got a large artery that tunnels right into the main shaft, while a whole network of smaller arteries blankets the outer surface and the ends. It's this constant blood flow that brings in all the nutrients and oxygen needed for healing and for that constant remodeling we keep mentioning. But bones don't work alone. Where they meet up to form a joint, they need a partner tissue to make sure everything moves smoothly and without any pain. And that partner is cartilage. Cartilage is fascinating stuff. It's firm enough to hold a shape, but it's also flexible enough to cushion and bend. But here is the crucial difference from bone. It has no blood supply, no nerves. And this is exactly why a cartilage injury, like a torn meniscus in your knee, is so notoriously slow to heal. There's just no direct highway for repair cells and nutrients to get to the site of the damage. And just like bone, cartilage is highly specialized for whatever job it's doing. You've got this smooth, glassy hyaline cartilage that caps the ends of your bones to make your joint slippery. You've got incredibly tough, shock-absorbing fibrocartilage in your spinal discs, and you've got super flexible, elastic cartilage that gives structure to your ear and your epiglottis. Every single one is perfectly suited for its location. Which brings us right back to where we started. Your skeleton is not static. It's a living diary of your physical life. This constant adaptation is carried out by two types of cells. You have osteoclasts, which clear away old bone, and you have osteoblasts, which build new bone. So when you exercise, you're telling your osteoblasts to build stronger, denser bone. When you're more sedentary, the osteoclasts can take over. It's truly living architecture. So the question I want to leave you with is this. What story are those cells telling inside of you right now?